Okay, get this. What if you could power a light bulb with, like, the dirt from your backyard? It sounds totally sci-fi, right? But a brand new study in the journal Energy Conversion and Management says it's for real. Today, we're going to dig into the science of generating electricity from, yep, plain old soil. I know, it sounds a little out there, but this research is asking a really serious question. As we're all looking for new sources of clean energy, what if a huge part of the answer was literally all around us, just waiting for us to figure it out? All right, let's get into it. The why behind this research is super important. We're facing these growing shortages of both energy and clean water all over the world. So, the scientists behind this were trying to find one single sustainable way to tackle both problems at the very same time. So, how on earth is this even possible? Well, it all comes down to a really cool scientific principle that taps into the power of something happening all over the planet all the time: evaporation. I mean, just think about the sheer scale of the energy we're talking about here. The study's authors point out that more than a third of all the solar energy that hits our planet goes into just one thing: evaporating water. That is a colossal untapped power source that's happening all around us every single day. The key to unlocking all that power is something called the hydrovoltaic effect. And it's actually pretty simple. When water flows across or through certain materials, it can generate a direct electrical voltage. You can think of it like capturing the energy of moving water, but on a microscopic, almost invisible scale. So here's how it actually works, step by step. First, the sun shines down and heats up moist soil, right? That makes the water on the surface start to evaporate. Now that evaporation acts like a tiny, continuous pump, pulling more water up from below. As that water, which has ions and salts in it, moves through the soil, it creates a separation of charge. And it's that constant movement of charge that gives you a real, measurable voltage. But of course, as any gardener will tell you, not all dirt is created equal. So the next big step for these researchers was to figure out which type of soil was the absolute best for the job. They basically had to find their super soil. To do this, they went on a bit of a scientific field trip. They gathered 9 totally different soil samples from all over Iran, picking them for their unique environmental properties. Then it was back to the lab to put them all to the test. And the results? Honestly, they were pretty wild. This chart here shows the evaporation efficiency, which is key for generating power. You see pure water? That's at about 57%. Some of the soils, well, they actually did worse. But then there was this one standout, the soil from Mashhad. Look at that. It hit an incredible 83.4%. So what was the secret sauce in this one particular soil? Well, it turns out it had this perfect mix of properties. Its dark color was great for absorbing more sunlight and getting hotter. Its high porosity meant it acted like a sponge, moving water really efficiently. And it was packed with organic matter, or humus, which plays a huge role in how the water moves. So what did all that efficiency actually get them in terms of electricity? On its own, this champion soil generated a maximum voltage of 205 millivolts. I mean, that's an awesome proof of concept. It shows this whole idea works with a completely natural, untouched material. But, scientists, they're never satisfied. They knew they could probably push this even further. So the next phase was all about taking their super soil and basically giving it a superpower. And isn't this the question that drives all innovation? They had a system that worked, but they really wanted to dial it in and see just how much power they could squeeze out of this simple setup. Their big idea was to add activated carbon, or AC. This stuff is super cheap, it's porous, and it's very black. And what's really great is they actually got it from used home water filters, which just makes the whole process even more sustainable. Okay, now you've got to see this comparison. When they added a 50-50 mix of activated carbon to that champion soil, whoa, the effect was just massive. The evaporation efficiency shot up from 83% to 92%, and the voltage? It jumped by almost 50%, going from 205 all the way up to 306 millivolts. That is a huge leap. And that 92% efficiency, that's a new record for this kind of system. It was the perfect team up. The soil provided the perfect plumbing for the water to flow, and the activated carbon's dark color and massive surface area just supercharged the light absorption and heat generation. So let's get to the bottom line, the final power output. The optimized mix hit a maximum power density of 0.21 milliwatts per square meter. Now, that's not going to power your house yet, But it is an incredible proof of concept for a system that's low cost and super easy to scale up.
Okay, let's zoom out for a second and look at the big picture. What does it really mean if we can generate power from, well, dirt and sunlight?
This is why this research is so exciting. The cost is ridiculously low. The materials are everywhere, they're natural, and they won't hurt the environment. The system is easy to make bigger, and get this, as a fantastic bonus, while it's making electricity, the evaporation process is also creating distilled clean water. It's tackling two of our biggest global problems at once.
For any new energy tech, the real test is durability. It's one thing for it to work once in a lab, but can it last? Well, the researchers really put their system through its paces, running it for 15 cycles and even in a continuous 5-hour test. And the result? It proved to be tough and dependable for the long haul. This quote from the authors really just sums it all up perfectly. They don't see this as just some lab experiment. They see it as a genuinely new, simple, and affordable tool that we can use to take on some of the biggest environmental challenges we face. So we kind of end up back where we started, but now the picture is so much clearer, right? Now look, there's still a long road ahead, but this research just cracks open an absolutely incredible possibility. A future where the ground we walk on doesn't just grow our food, but actually helps power our world. Just think about that.